Hello, what's up, guys? How are you doing? This is Crux Academy. So we have from the previous session we have seen the theoretical part of chapter 1, fundamentals of electric circuit. We have seen the basic concepts about the charge, the current, the voltage, and we have derived the formula for those, including the power. So in this session we're gonna solve some practical problems. So let's begin from the first example. The first example says that the total charge entering a terminal is given by Q is equal to 5t sine 4 pi t millicoulomb. So the charge is given in the function of time. So we are asked to calculate the current at t is equal to 0.5 second. So in order to solve this problem, we have to know the formula of the current. Previously, we have derived the formula for the current. So the current is the time rate of change of charge, is the derivative of q t. So dq over dt. So I is equal to dq over dt. Just we are simply expected to differentiate this equation. The differentiation of this in respect to time. So 5t sine 4 pi t. So the derivative, the differentiation will be 5 sine 4 pi t plus 20t cos 4 pi t milliampere. So simply the differentiation of this function will give us this. So we are asked to find the current at t is equal to 0.5 second. At t is equal to 0.5 second, just simply inserting 0.5 in t, So inserting 0.5 will give us 5 sine 2 pi plus 10 pi cos 2 pi, which is equal to, so solving this would be 0. 10 pi cos 2 pi would give us 31.42 milliampere. So the second example, let's come to the second example. Determine the total charge entering a terminal between t is equal to 1 second and t is equal to 2 seconds. If the current passing the terminal is I is equal to 3t square minus t. So we have given the current, which is 3t square minus t, the current in a function of time. So we are asked to determine the charge entering the terminal, the charge which is entering the terminal between t is equal to 1 second to t is equal to 2 seconds. So previously we have seen that we have derived the equation for the charge, the charge entering the terminal, which is the integration of the current I dt in time. So in order to find the charge, we have to integrate the current equation between t is equal to to t is equal to t. So now we have been given that I is equal to 3t square minus t. We are asked between the time interval, the amount of charge entering the terminal between these two intervals. So t initial is equal to 1 and t is equal to 2. So we are expected to integrate this equation. Just simple to integrate. The integration of this one would be t cube 3 over 3 is cancelled by 3 minus the integration of this is t square minus 2. Just simple. Inserting the time, simply we will get 5.5 coulomb. So let's come to the third problem. The current flowing through an element is given by this function. It is 4 ampere for a time between, when t is between 0 and 1 second. Again, 4t square when t is greater than 1. 4t is greater than 1. We are asked to calculate the charge from t is equal to 0 to t is equal to 2 seconds. So, as we have seen in the previous example, the charge is of the current in time. So, we are t is equal to 0 is t initial is 0 and the t final or is 2 seconds. So we are asked to find the charge between these two intervals. Okay guys, let's come to the third problem. The current flowing through an element I is equal to 4 ampere when t is equal to between 0 and 1, when the time is between 0 and 1, and the current is given by 4t square ampere when t is greater than 1. For t between 0 and 1, I is 4 ampere. But when t is greater than 1, I is given by 40 square ampere. So we are asked to calculate the charge from we are asked to calculate the charge from t is equal to 0 to t is equal to 2 seconds. So as you know, q is equal to the integration of I dt from t is equal from the initial t up to t. So in this case, we're gonna by dividing into two parts. For t in between 0 and 1 and for t when it is greater than 1. So we are asked to calculate, remember, we are asked to calculate the charge in between 0 and 2 seconds. So q is equal to, which is charge for 0 and for a time between 0 and 1, I is equal to 4 ampere dt, which is the integration of this function, plus when t is greater than 1, that we are asked to calculate the charge t between 0 and 2. So for between 0 and 1, this is the equation. For t which is greater than 1, that means we are only asked up to 2 seconds. From 1 up to 2 seconds, 40 square ampere. So the integration of this one is simply 40, and the integration of 40 square is 4 over 3 t cube. So inserting the time into the equation, just inserting this will give us 4, and for this one, inserting 1 and 2, it would give us, the solution will be 13.333 coulomb. This is the final answer.